Camera not record. Alrighty, let's get started with today's activity. I need heads up, I need us all engaged and participating today. I'll go ahead and tell you, first block about made me come unglued because of the lack of even trying. Guys, I'm okay with you trying and failing. I'm not okay with you sitting there silently and not doing anything. I cannot emphasize this enough. As long as you're trying, I'm going to be cool. But you can't learn if you're not trying. Because if you're not trying inside the classroom, legitimately, you're not trying outside the classroom either. You need to put your brain in gear to learn. And we do okay in this class, I will say. But you're capable of more. Stop selling yourself short. So, we're going to try to do it. We're going to do a quick recap to help us get started with today's activity. And then continue with Miss Courtney's activity that she developed before hopefully getting back to the textbook today. I need you to remember this. Pay attention to what you're trying to learn. It is hard to learn what you're supposed to learn if you don't know what you are supposed to learn. So, we are specifically focusing on these top two right here. Translating and dilating functions by non-constant values to create higher degrees of functions. So, if I have f of x equals x squared, and then I do g of x equals x minus 3 squared plus 4, versus f of x equals x squared, and I do h of x equals x squared times x minus 3. Which of those is it g of x or is it h of x that is transformed by a non-constant value?
H of x.
H of x? So that's what Jaden said?
There's a variable.
Liam, do you agree that that's transformed by a non-constant value? Why?
Are you asking me?
Not sure? Okay, so we need to understand why in a second. Jaden did say a second ago, but I want to see if others heard / understand. Tracy, do you agree that this is transformed by a non-constant value? Okay, why do you say yes? So, one more time.
You took the other
Did I take an x from that square? Like, what I mean by that is, it's not like I factored out or broke it up. Do you mean like I just reused that x? Yes? Okay. So I just want us to be careful on that language. So to like take something from would be like, oh, if I have the number 30, I'm taking a 6 from it and I'm left with a 5. Does that make sense? So I'm not taking anything from it. Still got the x's there. Okay, so let's clarify this a little bit. Jakeem, why is this non-constant? Huh? Well, is the 3 non-constant? It's a 3, so is that constant or non-constant? Huh? It's constant. That 3 is never going to change. I need you to understand that. But remember, I'm talking about this. Originally, I started out with x squared. So what did I transform x squared by? Not just x. X minus 3. First off, it looks like someone's struggling with that idea. So let me ask this question. Tamia, what type of transformation did I do with this x minus 3? If there had already been the x there, and then it would be a horizontal something, potentially. But remember, that x minus 3 was not in the original function, was it? So what transformation am I doing with this entire x minus 3?
Dilate.
How do you know it's a dilation? It's understood to be multiplied, right? So remember, I'm dilating by x minus 3. And that x is a variable. It can change, which is why it is non-constant. What are your questions from that detail? That recap? Okay, so we understand then that what's on the right here, h of x, has a non-constant transformation, whereas this has a transformation by a constant value. So what is different when we have a non-constant transformation? The shape changes. Remember, the very nature of that function would change. This parent function is what? What's the name of it? Quadratic. This transformed function is a quadratic. The nature of that function did not change. Would this still be a quadratic?
That'd be a cubic.
How do you know?
Because x squared times another variable would carry the
So the x to the third. Right? So that would actually be a cubic function. See how that dilation actually changed the function itself. What are your questions from here? Going once, going twice. I gotta stop losing my remote. There it is. Alright. And so what we're going to try to look at today more heavily is the relationship between the linear factors of a function and its zeros. So as a quick recap here, this is activity 2.1 out of the textbook. You will want this activity out when you work through today's task. Because I'll go ahead and tell you, the first handful of questions deal with exactly the same questions as these from the book. And the next handful of questions deal directly with the same ideas out of this from the book. So what should you all be doing right now? Getting that textbook out. I think you're looking at page 140 and 141 or so, maybe 141, 142. Children, do you not have your book? You just have your notebook with you? Huh? Yeah. Thank you, Tracy. Then talk with us in your group. You must be right outside your line. 141 to 142, I think. I'm just working through it.
Oh, sure.
Alright. Now, I need you to remember, last week we had this function that we were dealing with where we had x, and remember we had a line for y equals x plus 3. And we had several points. For example, we had -4, -1, -3, 0, -2, 1, -1, 2, 0, 3, 1, 4, and 2, 5. Remember, these are the points from that line. We all remember those details, hopefully, right? Yes, Mr. King. Thanks, guys.
You're welcome.
Okay. Oh, by the way, we said it is f of x. And what we tried to get was g of x. And how did we get g of x? Still on the page in the book, if you look.
Oh, you multiplied the the y's.
So the x times
The Y.
Yeah, x.
f of x, which f of x is the x. I need you to always remember, if you have that entire f of x or entire g of x or the entire h of x, what are we really referring to? The outputs, which is our y's. Okay, they are connected. So the way we got g of x is we literally took x and we multiplied it by f of x. So we took the x value, -4, times that -1 to get 4. Now we'll pause out, we'll say this. I think last week we did 2 separate tables, and you can continue to do that if you want. This is just an alternate way to do that. Notice the point would be the x stays the same, and the y would be 4. Good job, guys. So what was this point? What was this g of x? G of -3.
0.
0, right? So we have the point -3, comma 0. And then -2 times 1.
-2.
So -2, -2. So remember, we use that table to help us organize our information. Do we remember doing this last week?
Yes.
We good? So remember, you can do this just graphically, but the table does help. you need to pay attention to this idea of positive values and decreasing, negative values and increasing, because it will come up today. So here's where we are at this point. Everyone should have a function here, correct? Under f of x. And it needs to be in the form y equals mx plus b. We should have had it from what I saw in the calculator a second ago. And we are going to graph these functions. I can't remember if we got there in class last week at all, but we're going to graph these functions on the graph paper that you have. Do you know which paper I'm talking about, Liam? Yes, that one. Yep. Keanu, can you hold that up? Show it to everybody. Actually, just this one. This one. We should all have this out, ready to graph on. Now, I had quite a few students make mistakes first block because they weren't paying attention and slowing down. Everybody has what kind of slope for the function they wrote? Negative. So should I have a function that looks like this?
No.
This is increasing as you go to the right, so that is not a negative slope. Check yourself. It should be something like this. Now, I think most people are going to be okay with the graphing side. Just remember that you have a y-intercept and you have a slope. And how do we use a slope on the graph? Rise divided by the run. So we got rise and run to help us graph that. Now, some people were legitimately struggling a little bit, and that's okay. We need to recognize that in number 2, g of x is equal to what? X. And it's harder for some people to identify the slope of that function and the y-intercept. What can you all create, though, to help you graph this function? A table, right? Don't ever forget that. And I would point out, are there any transformations applied to that equation? No, so really we just have the parent function. So what's just one, but what's a good x value to use here? Just one, give me one. Okay, the value, x value of 2. We all good with that idea? If I substitute that in, literally I get y is equal to what? 2. So what's the y value? What are your questions before I release you to create your graphs within your small groups and help each other grow and learn? Now, I want to remind you, can you take some time on your own to think and make sure you have your graph working correctly?
Yes.
After you get done, though, what do you need to do? Talk with your group, check in with each other. Learning happens best in community and in fellowship and by talking, and not just talking about the math. I don't want to hear conversations about anything other than this math today. Is that clear?
Yes.
Let's get to work. You need a y-intercept. With that, did you put something with that negative 1/3 or 1/3 x? He has negative 1/3 x. So y'all didn't talk about it like the directions said to make sure we all had the same equation in that y-intercept? Well, before, I mean, they just literally, oh, you just haven't updated it since the calculator. I got you now. Okay, so what equation are we using? Okay, negative 2/3 x plus 4. There you go. Alright. And make sure you update that. So did you see what the issue coming out with when
Oh, you're going up one.
Yeah.
the y-intercept or the y-intercept wasn't
That's just
So what I was seeing happen was this, which isn't terrible. So one, I asked them to restrict the denominator because some of them have like bits. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then their x-intercept would be at that, which would be outside of the length that they have.
because theirs only goes to 9. So that was causing some of them some trouble. And then if they had something like, like that, it was okay, but, well, and it could go over there if it wasn't exactly that, but down to, hold on a minute, 1, 2, 3. So then, when they graphed these two, at least if they were doing it by hand, they weren't sure where the vertex was. Because it'd be somewhere between 2 and 3. But if they do, if they make the y-intercept double, then it would have intersected right here at the 5. Which is why I was asking them, because they would have 0 and 10, so they can easily average, and that would be one of the points that they have in the table automatically.
Okay,
So that's already wrong.
the y-intercept
And also,
needs to
points
be
are all.
double.
Because you're going,
What might be honestly better is
you
just
started
to
at
not
2,
sweat
that's
that detail and
all
have
one
it wrapped
intercept.
on calculator.
And then it went down in a negative slope.
But it needs to be 1 goes 2.
Wait, what?
So like, they,
I'm just
Yeah.
confused on the last one you said.
yeah. So if you're gonna have them do it by hand, we need the y-intercept double of the
Oh, okay, I see.
numerator, so that we can easily get the
Yeah.
average for that vertex be one of the points. But it may just be easier so they don't have to sweat that detail, just have them graph it on calculators. It'd still be better than what they have in the book of just having the, giving them the
I was showing you, I think you said just
for that first lesson. Does that make
You
sense?
just said grab.
So I think that was just something I would tweak looking at that lesson as it worked out. It made it difficult for some of them. Yes, sir. Remember, you need to have a y-intercept other than 0. What's your y-intercept right now? What's your y-intercept for this week?
There.
Huh? Well, that means you have a point where No, don't erase that. You have y equals x right there. That's fine. You still need, but you still need your other function, don't you? To draw a line through that, borrow a ruler, but you need to put your other function on there. Right, and then use your
It's a straight line.
that point, right?
It's like a reverse exponential right there, man.
What do you have on your desk to help you graph a line? Okay, you need to use it, because that is not a line. Nowhere close to a line.
You got the points, right?
Yeah, you don't have to erase the points, just erase the quasi-line. Okay, is that the only line we should have drawn there though, guys?
No, I was making sure it was on the right page.
Okay. Yeah, that's only number 1. Don't you also have numbers 2, 3, 4, 5?
2, we have to use a different color, right?
Which remember, there should be a pink box underneath y'all's desk, or someone's desk at least.
Alright, so we can work this thing on.
You'll have both your lines correct? Yep.
They use the same slope or just more?
It's just the parent function. And remember, this is why I said if you're struggling with just v of x equals x, then you can easily make a table without any transformation. Just substitute your x values in and your y values out. Okay? Do you have any questions before I go check on others?
I haven't used this in so long.
Yeah.
It's in my binder, I haven't seen it.
Okay.
It's a separate one of them.
So it's gonna be the same x value. It's literally gonna be the exact same x value.
What is this? Right, but what is the y-intercept? Notice how you went like this?
Which is the same as y. Is the same with x. So therefore, the x is negative 8, the y is negative 2.
You don't have the easier.
He was like,
That's not. Remember, Jesus, this is called the what again? The y value of the y. So should be on the y-axis. And then you should be going down one to
The
the
x value is the same as the y value.
Oh, so we
Yeah.
just.
Yeah, I see what you're
Negative y equals x.
No, 0, 2.
What's your equal one?
So the negative 1/2, the negative 1 is your what? Isn't this your slope? How do we calculate slope?
Yeah, y value is.
No, that's the slope intercept point of the line. How do we calculate slope? So here's your rise, there is your, so that's going up or down. And to the, yes, sir. Say that one more time.
Yours is still at.
Yeah, that's why the y value is 2. Yeah, but no, if you, so remember, it's y equals x, right? So if x is negative 2, y equals what? Negative 2. If x is negative 1, y equals. Right. Literally, what we're saying is whatever the x value is, that's what
I
the
thought
y
I knew what I
value
was doing, but apparently I don't. I know I'm not smart. I was trying to explain it the way that
is.
I.
How did I get this 2 right here?
But apparently the way I understood it is not the way it's gonna work. I tried.
But this is my function, g of x equals x. Right? So like, if I'm looking at g of 2, right, because the x value is 2. So 2 is my input, that means 2 is also going to take the place of x. So what's my output? Literally, what is it equal? 2. So what's the output? If you use a 1, so let's say I let x equal 1. 1 is the input, and that was x, so 1 is the output. Right? Remember, this equation is literally y equals x. So whatever x is, that's what.
You can RC work on program.
Okay? I would also point out, this is just a parent function. So give your x in, give your y out.
No, I spent the whole night grinding.
Alright, what are our questions that we have? Are we doing okay now?
Then I learned how to code the vault.
Yeah, that's why we have the marker box.
Fair enough.
Check one, how's it going? Huh? That doesn't answer the question. How's it going?
How much do you believe in that?
David, do you have any questions?
Right, tell my eyes like that. But you gotta have another one.
Okay, did you ask your group at all? So then how'd you get the points?
You gotta multiply.
For this function? Well, there's the points right there. Right? Like, look. Right in the middle. You see how you have 0, 4? Right? That's the x value 0, y value 4. What is this point?
I probably had to multiply the x and the y.
Comma?
You see?
So I want to point this out. To go from 4 to 2, aren't you subtracting 2? And you go from 0 to 3, you're... Hey, what's your slope again?
Yeah, it's a different equation, but that is the
You change your y and change the x. That's it. So you get the next one, we're going to subtract, but it's 2, and add 6.
that is gonna not be all day.
Alright? Kenzie, you know you have rulers all over the place, right? Please use them. Just, okay, but watch this.
No, sorry.
I got all that time and ask me to see if you're right. Before we go any
No,
further.
there's
Done.
nothing wrong, but I thought.
Now, we're just confirming.
I'm not saying he's wrong. I'm just not sure he's
Have you
right.
followed the next set of directions?
Exactly, so that's why we're trying to
And I
add
thought it was
information.
Fine.
Okay.
Okay. Yes, sir.
You got a question?
I don't have an answer.
So, we were trying to figure out how to do this. None of us thought he was graph because we were all just confused. He figured it out,
Mm-hmm.
but we're not necessarily sure if it's right.
Okay. You didn't think to use a graph or didn't think to use a table?
I meant the table was that.
That's your equation, basically, right? That is y equals x, or g of x equals x, which g of x is your y. So let's say x is negative 2. So I'm going to substitute negative 2 in.
Mm-hmm.
Y equals what?
Negative 2.
If x is negative 1,
Negative 1.
0,
0.
1, and 2, 2. Now, so you skipped sets of points, but you would have exactly the same points as those right through there. So there's your line.
It was how it was explained.
Okay?
It was how it was
Yes, sir.
Well, why
Say
did you
again.
say that?
Do you know how to communicate?
Bro, you don't be explaining, bro. You be quiet and you say.
The only thing you said was, I want to hear the, so I don't know.
He said, I want to hear what it's.
Yeah, I'm about to cover that.
I sat in that school.
Thank you. Thank you. Thank you. Alright. First off, I do want to say thank you all for genuinely putting in effort on that. It's helped save my nerves. I don't think it was perfect, but we did better overall. And I appreciate that. I want to ask this. I want someone who did f of x with a negative y-intercept. Is there anyone in here who did f of x with a negative y-intercept? So y'all did? Anybody else? Okay. So I want to use theirs because I want, actually first off I want to pause. Keyshawn, I need your eyes up here. Mackenzie, eyes up here. Jaquan, eyes up here. Thank y'all. Okay. I want to use a negative y-intercept because I want to contrast this with something later that I do want y'all to see. So what equation did y'all write? -4. Okay. So, don't forget, we have a y-intercept of -4 and a slope of what? So that means I can go down 2 to the right 4. So, and remember, I identify these things. Rise divided by run. Like, just because I'm not assessing you doesn't mean you shouldn't show your evidence for what you're doing. The whole point of me asking you to justify is so that you get in that habit all the time, thinking through your evidence. Oh, that's my slope, my rise divided by my run. Down 2 to the right 4. Same thing, up 2 to the left 4. And I want to point this out, right? So down 2 to the right 4. So how am I going up 2 and to the left 4?
The inverse.
It's not quite the inverse. It's actually a positive 2 divided by a negative 4. Those two things are equivalent, right? That's how I'm doing it. Up 2 to the left 4. So here is their function, and that's in one color. As a quick reminder for those of us who are struggling with this, for g of x equals x, remember, how else can you write that? What is equal to x? Just y. So don't make that harder than that has to be. When x is -2, what's my y? -2, right? Substitute -2 in. Literally y equals -2. When x is -1, 0. Well, so 0, 0, 1, 1, and 2, 2. What are your questions about how I got those points? So no questions. We good? Okay. And so obviously you can do more points beyond this. And so
the reason why I'm going through these details up to this point is I've already started to see some people asking the question about how to do number 3. What does number 3 say? Dilate f of x by g of x. Well, how many of you have already made a table for f of x? Some people have. Okay? Remember, actually, before I can do that, there's 2 ways to do this. One, here's my f of x, isn't it? What is this point right here? 0, comma, negative 4. Remember? Negative 4, right? So, if I were to dilate this value right here by x, what would I get? 0, comma, 0. I need a new color. They're all in my pocket. Does anyone have a question about how I got that point right there? This is good. Say again. Why did I multiply?
I'm just asking.
Say again, Katie.
Because you gotta dilate.
We're dilating. What operation is always associated with dilations? Multiplication. You good with that, Tyrese? Okay. And remember, what we are doing is that, are we affecting the x value whatsoever? No. The x is still 0. So I'm dilating f of x by x. So negative 4 times 0 is 0. So if I look at, say, this point right here, this is the point 4, negative 6. So the x value would still be 4. What's the y value going to be? Negative 24. Can I graph that? No. Okay, so I wouldn't put that on here. But don't forget, so I'm going to pause there for a second. So that's how you can do it on the graph. Personally, what would be easier is to make that table. I'm just going to use the points that are on this. By the way, I will point this out. Does anyone know another slope I could have done other than negative 2/4 that would have been the same?
By 2.
Say again?
Negative 1 divided by 2.
Notice how we have points here and here. So that negative 2/4 would have been the same thing as negative 1/2. That's fine. I just want to point that out. So that just gives us some more points. For example, this is 2, negative 5 now. And so I would get 2, negative 10. And that point I can actually work with. So there's that 0, 0. There's also this 2, negative 10 down here. So that might help y'all a little bit with getting some points, to notice those extra points there. But on the table, I'm just going to use the x values that I can easily see. So negative 8, negative 6, negative 4, negative 2, 0, 2, and 4. And I want to remember that f of x is equal to negative 2/4 x minus 4. And I don't have to do anything special. I can just look at the graph and get those points. But to get h of x, what am I going to do? Multiply what?
F of x times x.
F of x times x. So you can use that table to help you there. For those of us who are struggling with that number 3, does that help fix those issues? Okay? And try to catch mistakes as I see them happening. But let's work within our small groups to improve our understanding and to get that dilation down. But any questions before I release you back into your groups?
No.
Let's get to work.
There's at least one other point you can do.
Yeah.
Yeah.
Okay.
We doing.
Alright, 0.
So, keep that point right there.
I'm just doing only
You're fine.
I'm not doing
Here's the thing.
Just doing negative.
What you originally had was y equals,
Yeah, I
what
literally
equation
went
did
from
you
here
use?
to here.
Negative 2/3 x plus 4.
Got it, like right
And then
on
you're taking that negative 2/3 x plus 4, and you're multiplying that by x, right? Do you see an absolute value symbol anywhere there? No? Anybody know what type of function that should be?
You did all the positives?
Yeah, that's what I'm.
It's negative 2/3 x plus 4.
Okay.
And it's being multiplied just by an x. I'm asking you what type of function. If I were you, I might get out my textbook and I might look at page 141 and 142. Because it should remind you of what we did in the textbook. Wait, hold on a second. What is this red line? How did, hold on. If you substitute negative 2 in, y equals negative 2, right? If you have the equation y equals x. If x is negative 2, what is y equal to? Y is equal to x, and what is x right now?
0.
So what is y?
0, negative 6, negative 8.
If x is negative 1, y is negative 1. Remember, I already graphed that in orange up on the board. You see how to fix that though? So we're going to have to redraw that orange there.
This,
Yes, sir.
these x values multiplied by their y values, and you got
But you need a, yeah, look at your y-intercept there. So if you substitute a 0 in, what's negative 1/2 times 0? And then what's 0 plus 2?
So I multiplied.
So it should have been 0, 2. Remember, your y-intercept is
3,
2.
and I got negative 6.
Alright, then 0 times.
Can you fix it from there?
It was 0.
Looks like your slope's correct after that.
What's 4 times 0? That's 6 times negative 1. It was 8 times negative 1. There's only one wrong. Negative 16. So what else is wrong? What else are you trying to? What else?
I'm not saying there's anything wrong with it, I'm just saying don't look right.
So what are you trying to get?
That's all I'm saying.
But what's your evidence? Lee, you can't just ever say, like, I don't think this is right, or I think this is wrong.
I'm not
What's your
saying it's right or
evidence?
wrong, I'm just saying for my
So
eyes.
then you need to ask a question.
Lots of stuff.
So what's your question?
Lots of stuff.
You know, you're also trying to look at it upside down.
It doesn't matter if I
0
look upside
times
down.
2.
Yeah, I understand that. Those are right, yeah. I'm just confused on your numbers, really, because these numbers, where did you get
That's
this
from
from?
Mr. King.
Okay, but why are you getting Mr. Kenny? Why are you not getting the figure on the
Well,
graph?
yeah,
That's what I'm
everyone
saying.
have for number 2,
We literally just did that, that's why I was.
right?
But then where is the original?
You need to label your functions. No, label your functions from the beginning so you don't get lost.
This one,
Use to label before you get lost. Label your functions. Label your functions. Ladies and gentlemen, I want to point this out. You see right here where I said f of x is equal to negative 2/4 x minus 4? So these y values are coming from where? From that equation, right? Okay? Label your functions. If you just have a random table there with no equation, do you know where those points are coming from? Okay. Label your functions, please. It will help you significantly. Okay? Okay, you know that's supposed to be a full line, right? Now draw your line.
Killing me today.
Justify everything. Because the way the numbers you have that are planned out and everything, they're just confusing.
Correct, because what we're doing literally is x times f.
I know.
Tables so because that in
Alright, it's got one table here, there's a second one. Yeah, that's the
No,
second.
matter of fact,
But where's your first table?
Somebody write it.
David.
Do what?
Somebody write a little.
So what you have
Tina
is
told me it was right, but it's not right.
-8,
What's, okay, what's?
Unless I just didn't draw it the right way.
5, -4,
Oh, okay, so you're saying you dilated it and that's your new shape?
0,
Okay.
2, 1,
Where are your points that you dilated?
0.
Like,
And
so
keep
you
going.
dilated,
6, -5.
That's all I did. So,
okay, so you
Yeah, it's
got,
wrong or anything, it just looked weird.
So what we want
It's
is
wrong in my eyes. It's wrong.
literally
It's wrong, it's wrong in my
There's
eyes
F.
because it just looks weird.
There's f of
It's
x.
not necessarily wrong. It's
So-
wrong
do
in my
more,
eyes.
dilate the
Negative
negative on
product.
each side of that.
You don't have to, but, so like, cause yeah, I can't graph that.
Yeah, so like
So it's
do
negative 6 times
dilate the negative, or you might have to do,
I
I
can't
guess,
graph
negative
that, negative
3.
4 times 4.
Would be your next
Oh,
table.
I didn't write that.
That's
Like keep
negative
going, like
6.
you'll see,
But I thought like
0,
I thought like this.
2,
yeah.
0.
Oh, wait, so the
Six,
pink
negative
line
16.
is the
So I would
x.
just.
So you would do,
This one is.
Well, remember g of x
so how did, what did you
is
multiply to
equal
get these?
to x. So all of these x values, those are the same. as
Those
g.
what, x value, so this x value times what? Okay, yes. Yes.
Right, for g of x, remember, g of x
What's
is
the,
equal
what's
to
the
x.
equation for this?
Whatever x is,
And what
that's
equation
the
did
y
you guys come
value.
up
So
with?
all of these x values are the y values as well for this line right here.
X plus 4.
So graph your line and get those
So-
points on.
You're gonna need, a table or something to justify like these points, but then also tell me what points you're gonna need. You know what I'm saying? So you see how I have the table? That table?
Well, it's
And
x
that's
times
something
f
like
of
that to
x,
show like
right,
where
which
you're
really is
doing.
g of x times f of x, but g of x is x. Right, so g of x is x, and the next part depends on whatever your f of
Are you
x is.
confused? What are you, what are you still
So you
confused?
get your parabola.
You just think your thing's wrong? Well, so I think it just looks wrong because, like, the numbers that it does. But, that's why I was telling you to make a table, so you can really see what, uh-huh.
6, 8, 6, 0. Negative 10. Now you won't be able to go past negative 10 though, because what's the lowest y value you have? How's it going? Just gonna check on you in a second. Why y'all confused?
Well, not all of them, because
So we're just gonna.
Right, so
if you dilated that, it would go
what it
way
really
down.
says
Just
is
go like to
you're
the next one.
dilating
Do that next three.
by g. Well, g of x is just x. Right, so whatever the x value is, that's what g of x is. Because you have it on there, so g of x.
Okay. Now you see, work with that a little bit, see how those numbers come up. So then when you see whatever that one's supposed to be dilated to, it's gonna be
Using a different
next
color
somewhere
graph,
down
g of
here.
x equals
You can
x.
draw the line down. You wanna show like it's still, the shape's going down. You just wanna be able to get
But if
the,
you create that table,
it's supposed to be a problem.
negative 2,
And
y
you know that
value
because
negative 1. You see
you
how
dilated
y
two lines, right? You multiplied
So
two
then I have f
lines,
of x.
what's your new degree, the degree of the new function?
And so what
Wait,
we're
so
going
you
to
don't
say
have
is
to.
negative 8, 6, negative 6, 5,
Yeah, quadratic.
plus 2 every time. And then I think it's just one every time. That's okay. They get one now.
Yeah,
Is that right?
right?
-1, -2.
So those are the Y value points for your, for this one, yeah, cause what you're saying is it's X and F of X, and F of X is what?
So,
Yeah,
remember, H
so wherever you have -3, the output is
H
6.
is times F of X.
They just rebuilt that.
I used to know that one. I've almost
Right. That's all we did.
Right, bro?
That's what we did in the class. That's what
So then,
well, remember three things that are here. Well, this point won't be on there, right? Nor will this one. Nor this
so
one.
then in this
We
column,
can approximate that -1. What was
you
negative
can
two
write
times?
it as the point, so like, your X value would be -3, and what would your Y value be? Right, so then right, so be -3, comma -18. Put it in parentheses. Okay, so that would be -3, -18.
Well, if you take out of here.
Does that help? So you weren't doing anything wrong, it's just your numbers that you chose and the graph that you have to work with. The number's a little bit different, but it still works.
I can graph all of these. -2, -4, 0, 0, 2, 2.
Alright, y'all, I need you to get your graphs on there so that we can come back and have a whole class discussion about the next one. If you've already finished number 3, move on to number 4.
How am I messing you up? How did I mess you up? What? Say it. I can't help it if I don't know the issues. What's up? I won't tell you something's right if it's really wrong. What was the issue? What did I tell you to do? I told you to look at the book. What does that book look like? What is that? Oh. Oh. What do you mean I told you wrong? I didn't tell you jack wrong. You didn't think through what you should have known. It ain't my fault you didn't use your brain. But like we see that it's supposed to be a parabola, right? Yeah. Alright. Come on, get your parabola on there. You have your points. That's a question. Why do you say you had a question, right? Y'all good? Alright. Yes, sir. Say it one more time. You know, here's your X value, there's your Y value. What type of, that's your point. So you have the point -8, 0. There's an X value, there's your Y value. So you have the point -6, +6. Right? Alright. Actually, I'll give y'all, let's say, 1 more minute to get your points for number 3 down. We got to keep going from there. So get your points down. Like you have your points, yeah. So just, I think it goes up to here, doesn't it?
No,
Is it 0 2? Oh, it is. But I don't know where that point's coming from then. You need to be careful. Whoa. No, be careful. I need you to go here to here.
I think I got it.
To here. It doesn't go through that point.
I did 3.
Actually, it doesn't even go through that point. It goes here to the origin to that point. What type of function should that be? Yeah. Look at that top. Does that look like a parabola? Smooth it out. That don't look like a parabola. It shouldn't have a corner like that. Thank you. Thank you. Thank you. All right. I know some of us are still getting last details on that parabola, but I do want to emphasize this. Do not forget to label your functions, and remember, all we're doing is taking f of x, which is the what? The y, the output, and multiplying it by x. Now, technically, if you look at what the problem actually says, it says to dilate f of x by g of x, right? So, really, f of x times g of x. But, what is g of x equal to?
Why?
Remember, g of x is just the function notation kt for y, but if you look at number 2, g of x is equal to x. So I substituted x in, which is how I got this. So again, this is just for group 2, but check and make sure you did this correctly. I think I saw everyone doing the x times the y, or x times f of x, correctly. I think that's it, that, negative 10. Now, which of these points can I not graph whatsoever?
10, negative.
Well, the 4, negative 24, right? One thing that you may want to do to even help yourself out is you could go through and quickly write these points off to the side before you start trying to graph. This might be something I would suggest. Notice how I'm putting my x values with my y values. Okay. Negative 8, 0, negative 6, 6, negative 4, 8. Now, some of you may not have this many points, and that's okay. Just depends on the functions that you wrote. But this roughly is the function that you should see. No matter what shape should you see on the graph? Parabola. Hey, Caleb, what type of function did we have in the book last Friday?
Quadratic.
A quadratic, a parabola?
Yeah.
So what should we see here? A parabola? I called Caleb out because he was trying to give me grief how I led him astray when I told him to look at the book. Okay. Now, I need y'all to pay attention to 2 quick details because I've already seen a couple of students make this mistake, which will mess you up long term. So you need to look to see if you did this. I saw some students who just had that last point and they did this. Does anyone know what's wrong with that? Why not? It's not enough to say that ain't right. Why is that not right? Okay, first off, we're dealing with a parabola. Should there be a line there? No. And I need to remind you of this as well. If it's a straight line going down, can it continue to go to the left?
No.
But is this function continuing to go to the left? Yes. And so you need to be careful about that. With a parabola, you need to make sure it continues down, but it also continues left or right. I do not have a straight line. Check your graph and update that if you have an incorrect detail there on those end behaviors. Now, the next detail that I want to point out is please make sure with a parabola you do your best job to have a nice smooth curve up at the top. I'm trying to emphasize that it should not be a little corner at the top. It should not look like an absolute value at the top. It should have that nice smooth curve up at the top. Do your best. I understand that you're not going to be perfect at it. I'm not looking for perfection. I'm just looking for you to do your best. For you to recognize that it should be a parabola. Yes, sir. Huh? I mean, I can see it from here. It's okay. I just think you should be able to smooth it out a little bit better. All right. What are your questions before we continue? Anybody? Okay. So let's look at number 4 together, make sure we all understand 4 pretty clearly. 4 says write an equation for h of x. Well, immediately, what should we know for h of x?
The points.
In number 4, what does it ask for though? An equation. What do we know about h of x in terms of an equation? Yes, it's parabola, yes, it's quadratic, but how do we know that? Like, what did we do to get that parabola? We multiplied, we dilated, what by what?
F of x.
F of x by g of x, technically. Remember, that's what the original set of directions say, right? Dilate f of x by g of x. But we know a little bit more than just that. What is f of x equivalent to? Or technically, not just technically, equal to. For group 2, it's equal to,
It's your,
didn't you write an equation, f of x equals something at the top?
Yeah.
So you should write that equation right here. That's f of x. Whatever you put, that's what you need here. KT, did you write that down for number 4? Thank you, sir. So what should I put in the place of g of x?
just x.
Okay, so just x.
That'll work.
Alright, we good?
Yeah.
Okay. So what does it say in number 4 from there? Then use a graphing calculator. Do not do this yet. I want you to pay attention to something. So, I did this in the first block. Let me delete these. Okay, so x is going to stay the same. Alright, so I've got, what was it, -2/4 x. Actually, you can go ahead and put in your line. Go ahead and put those equations in. Depends on your functions, but we should have something like this. You should see on the calculator, yeah, you'll have to probably delete what was there before. By the way, remember what button can you always press to help you? You need to start with menu, right? Go to graph entry /edit.
Can we?
Graph your 2 linear functions. You can delete what was there before. Make sure it looks, that's the linear function. Make sure it looks like the graph that you did by hand. Liam, that is not the equation you graphed. Oh no, wait. You are missing something from your f of x. You gotta quit doing that.
Come on, man, get right.
Okay? Now,
How you get back to the equation?
well, what button can you always press? Menu. Now, before you type in your h of x, actually, quick show of hands if you are done typing in both linear functions. Okay, get your 2 linear functions in there. Need you to on delay. Muy rápido.
Wait a second.
There.
1x plus 0. 1x plus 0.
All right. So I need you to watch this. So I should have, so I have -2/4 x plus, no, -4, is that right? And then according to that, I just have times x. Wait, that's not the parabola I'm supposed to have. Let's look at that equation again. Does anyone see an issue with my equation?
It brings it back to the original parent function.
Made a mistake in typing that in, which most of you did too if you did not correct me when I wrote out h of x. Say again? Remember,